Coming to the next topic is latent heat. What is latent heat and what are the two types of latent heat? Latent heat of fusion. The next one, latent heat of vaporization. Latent heat of vaporization and latent heat of fusion. There are two kinds of latent heat. Latent heat. The meaning of latent means hidden. The word latent means hidden, hiding. Now, so as we discussed, as we know, if we heat any substance or any substance or material, the temperature of the material increases. The temperature of the material or a substance rises. However, it is in case of a change of state of substance takes place. Is it not so? Is it not so? When a substance when a change of state of substance takes place, that means, as we discussed different changes of states of matter, that means solid to liquid, liquid to gas, solid to liquid, liquid to gas, the temperature is constant when there will be a change in the state of matter takes place or change in the state of substance takes place. That means when ice melts into liquid, the temperature of ice is constant. Temperature of ice is constant until the total mass or the total amount of ice melts into liquid. That means on heating, the temperature of the substance increases up to certain level. After that, once it starts to change its state, the temperature of a substance is constant until the whole substance convert into other state. Then what will happen? Why this happened? Then we are heating continuously. Where does that heat energy goes? That heat energy absorbed by the particles and hidden, hide in the substance for what? To break the force of attraction between the particles or molecules. Between the particles or the molecules of a substance. So that hidden energy is called latent heat. That means the amount of heat energy, the amount of heat required, the amount of heat energy required to change the state of matter or substance. Some amount of heat energy required to change the state of substance or matter, that is called latent heat. Latent heat. So this latent heat or the supplied heat energy absorbed by the particles or the molecules, of substance, hidden, hide, absorb. That absorbed heat energy is utilized for breaking the force of attraction between the particles or the molecules. Between the particles or molecules of the substance. So, to change the state of substance, it must be break the force of attraction between the particles. If no breakdown of force of attraction between the particles, a matter or a substance cannot change its state. To change state, we must supply some heat energy to the particles or the molecules of the substance. That energy is absorbed and utilized for breaking down the force of attraction between the particles and change its state. This is how. There are two types of latent heat. One is latent heat of fusion, latent heat of vaporization. Latent heat of fusion, latent heat of vaporization. As we know, fusion means the process of conversion of a solid into liquid. The process of conversion of a solid into liquid. So, to convert a solid into liquid, we need to supply some amount of heat energy. That amount of heat energy is called latent heat of fusion. So, the amount of heat energy is required to change 1 kg of solid to liquid. 1 kg of solid to liquid. The amount of heat energy required to change 1 unit or 1 kg of solid into liquid is called latent heat of fusion. Latent heat of fusion of ice is equal to 80 calorie per gram or 334 kgV by kilojoules by kg. 334 kilojoules by kg is the latent heat of fusion. Here is a formula for latent heat. L is equal to Q by M. L is equal to Q by M. So L means latent heat. Here Q is equal to amount of heat. M is equal to mass. So heat measured in terms of calorie or joule. Then mass is measured in terms of kilograms or grams. So unit of latent heat is calorie by gram or joule by kilogram. Calorie by gram or joule by kilogram. So the amount of heat energy required to change 1 kg of solid into liquid. The heat energy is called latent heat of fusion. Latent heat of fusion. What happened? What happened when heat energy is applied to ice? For example, let's consider in a speaker we have taken a ice cube. We have taken ice cube. That means, for example, consider 100 grams of ice cubes or ice taken in the beaker, and on heating, what will happen? It converts into liquid. So before heating, the temperature of ice is, for example, minus 4 degree centigrade. Right? So we have taken the ice at minus 4 degree centigrade. So to change it to liquid, what will happen? We need to supply some heat energy. So on heating, the temperature of the ice increases from minus 4 to minus 3, minus 2, minus 1, up to from minus 4 to minus 1. The temperature of ice goes on increasing until it starts melting. So once the temperature of the ice reaches 0 degree centigrade, at that temperature ice starts to melt. Ice just start to melt, not melt completely. So once the temperature of ice reaches 0 degree centigrade, there is no change in the temperature of ice. Until 100 grams of ice convert into water. But we are heating continuously. Where does that heat energy goes? Then that heat energy is absorbed by the molecules of ice and particles of ice to break down their intermolecular force of attraction. So the supplied heat energy utilized by these particles and molecules of ice to break down the force of attraction between the particles. So here no change in the temperature of ice when it starts melting until to complete the melting of total amount of ice. So we have taken 100 grams of ice at 0 degree. At 0 degree. At 0 degree centigrade. So once it reaches 0 degree centigrade, after there is no rise in the temperature. So there is no rise in temperature during the melting of ice. From 50 to 0 degree temperature increases. Once reached 0 degree, there is no rise in the temperature because of latent heat of fusion. That heat energy utilized to break down the force of attraction between the molecules of it until the total amount of ice melting. Total amount of ice is converted into what? This is called latent heat of fusion. Latent heat of fusion. So then coming to latent heat of vaporization. Latent heat of vaporization. We know what is meant by the latent heat of vaporization. Vaporization means the process of conversion of a liquid into vapor or gas on heating. To change a liquid into gas, we need to supply some heat energy. So the amount of heat energy is required to change 1 kg of water, for example, or liquid, 1 kg of liquid or water into vapor or gas. So the amount of heat energy is required to change 1 kg of substance is known as latent heat of vaporization. Latent heat of vaporization. As we know, water, for example, water change into gas. So latent heat of vaporization of water is 540 calorie per gram or 2260 kilojoules per kg. That means when we heat the water to change its state from water to water vapor, how much heat energy is required? 540 calorie per gram. Here also same happen. So if you take the water at 5 degrees centigrade, so on continuous heating and supplying heat energy, the temperature goes on. The temperature goes on increase to 100 degree centigrade. We know at 100 degree centigrade, the water starts or convert into vapor or start changes into vapor. So 5 degrees centigrade to 100 degrees centigrade, the temperature goes on increases. Once reach 100 degree centigrade, there is no change in the temperature. 100 degree, how much time we have to heat, how much heat energy we have to supply. Once reach the temperature 100 degree, there is no change in the temperature. Of water. So that amount of heat energy supplied to the water, utilized by the water molecule to break down the force of attraction between them, and starts to boil. Water starts to boiling, but no change in the temperature. So that amount of energy is utilized. To change 1 kg of liquid into gas is called latent heat of vaporization. Latent heat of vaporization. So when ice melts into water, while water starts to boiling or starts to vaporize into stream, in both cases heat energy absorbed by the particles to break down the force of attraction between them. That's why while ice starts to melting, no rise in temperature. While water starts to vaporize, no change in temperature. The heat energy is hidden to break down the force of attraction between the particles.